Now let's take a look at superconductors. As you saw, when we cooled off our coil of copper wire, for most substances, as the temperature goes down, the resistance goes down. For some substances, when it's cooled below a critical temperature, the resistance drops to 0, and it exhibits superconductor properties. Many elements exhibit superconductor properties at atmospheric pressure or higher pressure, or in the case of carbon, in the nanotube form. But these have critical temperatures near absolute 0, limiting any practical applications. So scientists have been trying to develop materials that are superconductors at room temperature. The highest temperature materials they have developed so far have critical temperatures not far above the temperature of liquid nitrogen. The superconductor that I'm about to show you is called a Ybco ceramic superconductor. Our superconductor kind of looks like an Oreo cookie, but the actual superconductor is in the black part of the superconductor cookie here. And the cream filling is actually a sponge, and that's going to soak up some of the liquid nitrogen that's going to help keep it colder longer. If you notice, at room temperature, when I put it on this set of neodymium magnets, it's not affected by those magnets at all. Now I'm going to take our superconductor and I'm going to submerge it in liquid nitrogen. The superconductor has been submerged in liquid nitrogen for a couple minutes. So prepare yourself to be amazed as I take the superconductor and I put it back on the magnets. And you'll notice it's floating in the magnetic field above the magnets. But the interesting thing is, it pretty much stays in the orientation and position that I placed the magnet in. At room temperature, the magnetic field passes through the superconductor, but when it gets below its critical temperature, the magnetic field is expelled from the superconductor. This is called the Meissner effect. Our superconductor, however, is a thin ceramic that allows the magnetic field to pass through it in discrete locations. This is called trapping or pinning of the magnetic field. This pinning holds the superconductor in the orientation that it is placed. Now let's see what happens when we place our superconductor on our disk magnets. As you can imagine, hours of fun for the whole family. But wait, there's more. Now we're going to take our superconductor and we're going to place it on the table and see if we can pick it up with our magnet.